Hello everyone, you're welcome to Dr. Wankwa Mentorship. Today we are going to explore the concept of polynomials and I'll be guiding you through a problem that will help you understand the remainder theorem. Don't worry if math seems difficult or tough, we are going to break it in such a way that is easy to understand. Let's dive in. On the board we have our problem which reads, when the polynomial p of x equals ax cubed minus x squared minus x plus 6 is divided by x plus 1, the remainder is 4. The value of the constant a is. Our task here is to find the value of a, and this problem is ideal for applying the remainder theorem. Now that we have our problem as on the board, let's explore the remainder theorem which will help us solve it. The remainder theorem states that if a polynomial p of x is divided by x minus c, the remainder is p of c. Now that we have stated the remainder theorem, let's explore the reasoning behind this theorem. The idea behind this theorem is rooted in a basic arithmetic concept which you, including myself, saw way back in primary or elementary school, whichever one your school or educational system recognizes. Now, remember when we divided 17 by 3, we got a 5 remainder 2. Now, this can be written as 17 divided by 3 equals 5 plus 2 divided by 3. Now, multiplying both sides by 3, we have times 3 gives us 17 equals 5 times 3 plus 2.
This idea works similarly when dividing polynomial functions. So we
as x minus c times some cure of x plus r, where x minus c is what we call the divisor, cure of x is what we call the quotient, and r is what we call the so that's it. Substituting c for x, that is when x equals c, we have that p of c equals c minus c times cure of c plus r, our remainder. So which equals c minus c gives us 0 times our cure of c, remains cure of c, plus r. 0 times cure of c gives us 0. So 0 plus r, which equals r. So indeed, our remainder is p of c.
Notice that the divisor is linear. The remainder is a constant. If the divisor is quadratic, as here, the remainder is linear. That is a function of x. In our case, we have a linear divisor, x plus 1. So we can rewrite this divisor as x plus 1 equals x minus, in bracket, x minus 1. So we can find the remainder for this given polynomial by evaluating p of negative 1 as per this theorem. Evaluating p of negative 1, we have that p of negative 1 equals a into negative 1 cubed minus negative 1 squared minus negative 1 plus 6, which equals a into, we have that negative 1 cubed is negative 1 times negative 1 times negative 1. Negative times negative gives us positive, times another negative gives us a negative 1. So a into 1 minus, as already established, negative 1 times negative 1 gives us positive. So we have positive 1 here, minus, now negative times negative gives us positive. So this negative 1 here becomes, this negative sign here cancels, becomes positive 1 plus 6. So we have that this equals negative a minus 1 plus 1 plus 6. Negative 1 plus 1 is the same as 1 minus 1, which gives us 0, so which equals negative a plus 6. So the original polynomial function is obtained by fitting in the value of a, which is 2. So the original polynomial function is p of x equal to 2x cubed minus x squared minus x plus 6. I hope this explanation helps you understand the concept better. Now, here is a practice question for you. Find the remainder when f of x equal to 1 minus x raised to the power 5 is divided by x squared minus 1. Remember, practice makes perfect, so try solving similar problems to reinforce your understanding. I will share my WhatsApp number in the comments so we can go over similar practice problems. Thanks for watching. Do not forget to subscribe to Dr. Mentorship for more math tutorials.